Alright, there is no great secret to balancing chemical equations. It's all a matter of being persistent and following the process. Okay? And never give up. Alright, so let's see, let's put down this equation that everybody seemed to have trouble with here last night. H3PO4 aqueous CaOH sub 2. What? Oh, there you go. Well, I need to do that, huh? That's helpful. Then water, and then calcium phosphate. Actually, that's the one I had to change. That's a solid. That's not supposed to be aqueous. I had to look at it again. I didn't realize I'd changed that already. And it is supposed to be a solid. So we'll change that in a minute when it has a chance to dry. Alright, so the first thing I'll do is make a list of all the atoms we have in this equation. And as complex as that all seems, we actually only have 4 different kinds of elements. We've got hydrogen, got phosphorus, oxygen, and calcium. And we're going to make this grid for the atom inventory. And make this a solid over here. All right. We're going to count all the atoms that we have in the equation. We've got 3 hydrogens here, and over here there's a hydroxide that's inside of parentheses, and the 2 outside means there's 2 of everything that's inside. So that means we have a total of 3 plus 2 hydrogens. Now, if you're not feeling well like me, or if you're just kind of new at this and you're having trouble keeping up with all the numbers, write it down. Okay, writing it down is a way of not having to keep up with it. Okay, so I know I have 3 hydrogens here, and 2 times 1, I've got 2 here. That means I have 5 hydrogens. Okay, I have 1 phosphorus, and oxygens are also one of those that can kind of be hard to keep up with. I've got 4 here, plus 2 times everything inside, so that means I've got 2 here. So initially, at least, I have 6 oxygens, and I have 1 calcium. On the other side, I've got 2 hydrogens here, and that's all I have to start with. I've got a 2, that's a 2 outside here. Make sure it looks like a 2. So that, and this is only 1 phosphorus in the phosphate. That means I have 2 phosphoruses, or phosphori perhaps. I've got 2 times 4 oxygens here and 1 here, so let's make sure we keep up with it. 1 oxygen there, 2 times 4 here, means I have 9 oxygens to start with. And I've got 3 calciums. Now the rule I've given you about what to balance when is that we're going to save oxygen for last and hydrogen next to last. So let's start with phosphorus. I've got 2 phosphoruses on the right side, only 1 on the left. If I'm going to have 2 phosphoruses, remember I can only use coefficients. These are balanced formulas. Can't touch the formulas. I can only use coefficients to get all the atoms to balance out. So in order to get 2 phosphoruses, I'm going to put a 2 in front of this, coefficient 2. And that's going to change not only the number of phosphoruses, it's going to change everything else there, the hydrogens and the oxygens. Let's go and change this to 2. And go back and count both the hydrogens and oxygens. Alright, so I have 2 times 3 hydrogens here. That's 6. Plus I have the 2 hydrogens over here, so I have 8 hydrogens now. And then the oxygens. got 2 times 4 or 8 oxygens, plus the 2 times 1 or 2 oxygens. So right now I have 10 oxygens. Okay, got the phosphorus is balanced for the moment. Now, since we're going to save oxygen for last and hydrogen next to last, let's go to calcium. I've got 3 over here on the right-hand side. To get 3 on the left-hand side, I need a coefficient in front of the calcium compound. So I'll put a 3 in front of this. That's going to give me 3 calciums, but again, it's going to change the oxygens and hydrogens. Maybe I can add all those up again. Hydrogen. 2 times 3 is 6. And then 2 hydrogens. This 2 here means I have 2 of everything inside, so it's 2 hydrogens times 3 or 6 hydrogens makes 12. Okay, so let's see. Hydrogen is going to be 12 now. Is that right? 2 times 4, no, wait a minute. Yeah, 2 times 3 is 6, and 6 makes 12. Alright, now, and I still have to balance the oxygens since I changed those. So I've got 2 times 4 or 8 oxygens, and then the 2 oxygens here times 3, 2 times 3 is 6, that makes 14 oxygens, right? Okay, got the calcium's balanced and the phosphorus is balanced. Since I want to save oxygen for dead last, the next thing I'm going to go to is the hydrogen. Yeah, what I'm going to do is I need a coefficient in front of this species that's going to give me the 12 hydrogens, right? And that would be a 6, because this is the only species that has hydrogens. And so that changes the number of hydrogens to 12. And it changes our oxygen number on the right-hand side. So let's go back and add up all the numbers here. 6 times 1 is 6. 2 times 4 is 8. So that's 14 oxygens. And we're balanced, right? Okay. So how many of you were able to get this one right? 1? Nobody else? 2? 3? Tori, you saying you got it right? Or you have a paper that's right?
Paper's right.
All right. So is that your paper? Okay. So a few people got it right. Okay. And that was number 1 on the homework. All right. We have to classify this as well. There's a polyatomic ion in this formula. So this formula then is in 2 parts. You've got hydrogens on the front and the phosphate on the back. And we look over here and we can see the hydrogen on the front ended up on the water, and the phosphate that's on the back ended up over here in the calcium phosphate. Okay. Let's see. We have a calcium here, which ends up over here with the phosphate, and then we have an hydroxide here that ends up over here in the water. One of the reasons I write water like HOH in these kind of equations is so that you can see where they're going. So the front part of this ends up with the back part of that over here, right? And the front part of this one ends up with the back part of that one over here. Okay? So that is, let's see, we've got a species that has hydrogen in the front that makes it an acid. We have a species with hydroxide in the back that makes it a base. So this is both double replacement and acid base. Yeah, we explained that yesterday. Huh? I I said that since all the acid-base reactions we're going to be doing in here, at this time anyway, will be double replacement. You have to name them as both. You have to classify them both ways.
Anything that's double replacement is acid.
No. Anything that's acid-base is also double replacement. There are double replacement reactions that are not acid-base. Okay? Now, if we were really high-end here and doing college-type work, you know, you probably could figure out that an awful lot of other double replacement reactions are acid-base, but it uses this theory of acids we're not even going to get into in here. Okay? All we want to do is look at the simplified versions of acids with hydrogen on the front. It's the simple versions of bases with the hydroxide on the back. Okay? So if you have hydrogens here and hydroxides on the back here, and they make water, you got an acid-base reaction. If it's double replacement. Okay? All right. Problem number 2. CaBr2. K2SO4. CaSO4. KBr. List all the atoms we have here. We've got calcium, bromine, potassium, sulfur, and oxygen. One calcium, 2 bromines, 2 potassiums, 1 sulfur, 4 oxygens. 1 calcium, 1 bromine, 1 potassium, 1 sulfur, 4 oxygens. I need to get we're going to save oxygen for last, but it's already balanced. Let's start with bromine. In order to get 2 bromines on the right, I need to put a coefficient 2 here. That's going to change the number of bromines to 2, but it's also changing the number of potassiums. And that changes to 2. And that one's balanced already. Alright? That was pretty straightforward and easy, right? Catch the calcium over here on this side moves over and joins up over here with the sulfate. That's the back of this formula here. And the potassium moves over here and joins up with the bromine. Okay, so we're basically switching that two-part formulas, and they're switching front and back. Okay, and that would be the definition of a double replacement reaction. But it's not acid-base because there's no hydrogens and hydroxides. 3. Got CO2, H2O, and we get H2CO3 aqueous. So we've got carbons and oxygens and hydrogens. Excuse me. 1 carbon, 2 oxygens here and 1 over here. That's 3. And 2 hydrogens. 2 hydrogens over here, 1 carbon, 3 oxygens. And it's balanced already. I have 2 simpler compounds joining together to make a more complex compound. And that's, by definition, is what synthesis is.